Yo, what is up, everybody? My name is Alicia, and I'm excited to be back. We are on week 3. Does anybody else just need a nap? Like your head hurts, you're tired, and you're questioning, why are you doing this? If so, those are all adorable feelings. I actually too could use a nap as well, but I'm super excited and pumped up for this one. Today we are going to be working with DynamoDB to actually back up our data that we're getting from our applications. And to be honest, with each week as we progress, we add more skill sets onto your tool belt that you'll be able to use to stand out amongst the crowd. So some cool things that we have going on with automating, getting the data, automating some backups, and just really like building out the resiliency of this thing. I hope that the takeaway from this project is that there's like so many approaches and so many bells and whistles that you can add on to enhance the process and your infrastructure as you decide to build it out. And there's really no one true path to accomplish these things. So without further ado, let's just jump straight into the code where we love to be at anyways. Let's get it. Okay, so I hate to be the bearer of bad news here, but we actually are going to be using, for those of you who are following along synchronously or in order, we are actually going to be using our NCAA highlights application that we built out last week when we were focused on Docker and containers. The reason why I chose this application is because really the intent of this lesson was to take something and back the data up, not necessarily to do something new. So the overall architecture in large remains the same. When we jump into the code, I'll show you guys some differences and some edits that we made to kind of enhance this experience. But the key takeaways that you want to look into from your architecture perspective is that instead of grabbing one video like we did last week when we were dealing with containers, this time we're going to be grabbing either the first 5 or the first 10 videos within that file. So we'll have more data actually being extracted. Now, what you'll see is that the data is actually going to go to 2 places. It's going to go to our S3 bucket to store, right, those videos. And then it's also going to go to DynamoDB as well and store it there for a backup. So I'll kind of show you guys the lay of the land and kind of what DynamoDB, some of the features that it also has. But then, similar to like we did last week, we'll also use AWS Elemental MediaConvert to go and convert those files or enhance the audio and experience of that. Now, jumping into DynamoDB specifically, you'll see here that we have tables, sports highlights. Like any good instructor, to some point, I went in front of you guys and did a little bit about this like any good instructor, I went in front of you guys and did this project about like 75%-ish of the way there. Now, when you talk about why DynamoDB, really there's a number of features that it has, right? Amazon DynamoDB, it's a serverless NoSQL database that scales automatically. So that's definitely helpful for high read and high write applications like this specific project. It also has fast read and write, so low latency, great for real-time applications if we were, processing these things in a real-time manner. Like we said, also, it's going to be able to handle that auto scaling. So if the API data increases automatically, we can scale up. It is a pay per use pricing, so we don't have to provision these resources manually. And then it is also highly available. So we have multiple region replication, which is important in the data world. You want to make sure that if one region goes down for whatever reason, outages happen, you have that resiliency baked in and your end users don't experience any kind of difference. Like essentially an outage happens and no one even knows what's going on. Now, how we're going to be using DynamoDB specifically here, though, we're going to be storing our sports highlight data. So every time a new sport highlight is fetched, they're going to be stored in our DB, and each highlight entry is going to include a unique ID, which we call a primary key in the data world, the event date, the league name, the video URL, and we have some additional metadata. So let's go ahead and jump into the table items so you can kind of see what we are getting here, right? So as you can see, we have the ID that is going to be unique. We have a channel, so kind of where it's coming from. Some of these are null, meaning there's no data, but the Big 12 Conference, Mountain West Coast Conference, a quick description of the actual highlight itself. So as you guys remember when we took a peek at that JSON data last week, and I'll kind of go over this for those of you who aren't following along, that way you're not completely lost. Within the JSON data, it gives a description of the highlight. So Duke Miles is a player in the NCAA, and he is going for the big time stuff. Pause. Whatever that means. But yeah, even more importantly, this is the URL that it's going to go and download the video. And then we also have the fetch date here. So I have ran this quite a few times, tweaking some things so you can see what day this data came in and where it came from: YouTube, ESPN, etc. This is a little bit about the title, so the game, or like who won, and then if it is verified or not. So a lot of interesting metadata that is stored here for a duration of time. Now, one of the key benefits to this, though, specifically like DynamoDB, is that we are able to, sorry for clicking around, getting a lay of the land. We are able to configure backups here, right? So there's two types of backups that you can set up. As you can see here, we do not have anything configured, but you have a point in time recovery, which is going to provide that continuous backup for your DynamoDB data for up to 35 days. So this is something that you could implement to help you protect against accidental write or delete operations. And then we also have the ability to create scheduled backups. So if you need something longer than that 35-day window or period, you could set automated backups to save that data. So when you start to think about it, right, you're like, well, why don't we just have this thing back up every minute and we'll never go down, right? Well, obviously this costs money to do things. So you want to put on your architect hat or your engineer hat and say, okay, based on how often I'm running this application to get this data, what makes sense, what backup schedule makes sense. So maybe you come to the conclusion that NCAA games only happen Thursday through Sunday. I obviously do not watch basketball, so spare me if I completely got that wrong. But we only need to, one, run our application Thursdays through Sunday. Most games are typically in the evening time, let's just say 7 p.m. So since we're getting highlights from that, maybe we could schedule, you know, our application to go and search for the highlights around like midnight, right? That way the game has time to conclude and upload it to all the different sources. You could also dig into the API and see like how often that data is brought in. But okay, cool. So we have it happening Thursday through Sunday, 12 a.m. So that way it's after the game is finished. I probably want to schedule my backup for maybe like 12:30 or 1 o'clock in the morning. So that way, as soon as that data is brought in, the backup is also snapshotted and I'm able to store that for a longer duration of time. Cha-ching! Shout out to you. Put it on your engineer hat. Now, we'll talk about DynamoDB a little bit more and kind of how we work with it, but let's jump into the scripts and look at what we have changed. And for our new friends, let's go over really how this architecture is working as a whole. So we are using Cloudwatch here for our logs. So we can come here and view logging a little bit later. As you guys can see here, fetching the highlights, grab the highlights and store them in that S3 bucket. That is just the JSON output of that. So that basically means that it's just text, right? Letters, numbers, whatever. After it stores that highlight there and in the DynamoDB, it's storing the record with the key here. So it's showing us the output of all of those records. And then it is going to begin processing and downloading those videos and taking it into MediaConvert. Another thing I want to show you guys on the DynamoDB that you can set up is the ability to export or import from S3. So if you wanted to, you could send this data from this table here back to an S3 bucket itself. So just two things I wanted to highlight in the UI in regards to DynamoDB and the Cloudwatch logs. But jumping into the code, first things first, everything starts off with an environment variable. Where would we be without them? For those of you who have been following along, you kind of know the name of the game to this. Anywhere you see these kind of inward carets, you are going to want to delete that in entirety and replace it with contents, right? So that is where the information is specific to you. And in the README file, I have the steps on how you can go and find and retrieve that information, like your access keys and some of the other things that it asked for, like around the subnet and the security group. For those of you who followed along last week when we did the containers, you'll be able to reuse that security group and that subnet. If not, you can really approach it in two different ways. You could either go back and do that lab first and do this one, so that way you kind of understand some of the architecture, or you could just kind of look into the steps here on how to go and grab that relevant information. So kind of up to you on that piece, but largely the same. What region we're defining, some task details and information here, where to find the ECR image. Once again, we kind of went over that when we talked about containers last week. So if you're not strong on that, feel free to ramp back up. The API URL, where we're getting the data from, the host, the key, the bucket name. Everything is largely looking familiar to last week. Some new things that you'll see added in down here, though, is the DynamoDB table. So we're actually going to name that here. And then what are some of the Cloudwatch settings that we need to configure. And then last but not least, we pull our subnet and security group information here. Our invariable file is essentially protecting us from having to hard code anything. And we are actually doing something different in this one. You'll see when we jump into the README, we're going to use something, we're going to install something called getText. It has a feature that allows us to swap out some of the variables in our templates that you'll see here. Now, I didn't structure this the best in this folder. My apologies for not cleaning this up. I probably could have separated out some of the things that dealt with policies versus the actual like application and scripts in the Docker file itself. I might go back and redo that. So if your structure doesn't look the same as this, that's okay. The way that we do this is like these videos are static, meaning this is shot today at February 4th at 6:30 p.m. Eastern Standard Time. And I'm going through this, but as you all give us feedback or find things that we can improve, we do update the README. So the README is the source of truth. It's not a one-to-one comparison, sorry for that, but we try our best to get it right the first time. But anyways, jumping into the Docker file, this week isn't about containers, so I won't really go into it too in depth. But the biggest changes for those of you who were with us last week is that we needed to rename the file that is processing the videos, because last week it was called like process1video.py. This week we are grabbing more videos, but this is essentially telling the container what steps to execute to go and build it out, right? Now, in the config.py, right, this once again is a file that is dealing with actually like building or configuring out the application itself. One of the only things that you'll see we added in is some information around the DynamoDB itself. Actually, let's do this in synchronous order. So let's start off with fetch.py. So fetch.py is going to call the sports highlights API. Is going to extract that video in the URL and save that Json data to S3. Similar to like how we went through this last week. So we're not going to spend a lot of time on that code. But what you will see down here is like we also have another function that is going to store the highlights in DynamoDB. It's also going to create that data key so that way it stays unique for us as well. And then process highlights. This is the main function to fetch and process those basketball highlights. As far as the MediaConvert process, this file right here just kind of goes over how we're going to enhance our audio. So if you wanted to do anything with tweaking the settings or changing anything like that, this is a file where you can make those modifications. Kind of touching on this at a high level just because we went, like I said, we went over this last week. But some key changes to the media process, right? First and foremost, we have changed how we are getting our data. Instead of looking at a static date, we are now getting our data based on today's date. So if you run this tomorrow, you will be grabbing data from February 5th. and et cetera, et cetera. Another thing that we changed is the amount of videos that we're actually grabbing and processing. So instead of just going and looking for one video in that URL, we are now grabbing, I believe 10, let me see, 1, 2, 3, 4, 5, can't count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah, probably, yeah, 10. And of course I should know that because we set the limit right here to 10. I kind of messed around with it at 5 and at 10. Requirements.text, like we said, just kind of some of the requirements to run this task on the container. And then last but not least, run all.py. This just gives us a logical step to actually run and execute everything and kind of print what is happening along the way. This allows us to make sure that as each script execute, we give AWS some time to kind of create these resources, stabilize, and use them. So sorry to brush through that. If that was super fast and still confusing, like I said, go back to the video last week where we talked about containers. I kind of go through this code a little bit more in depth, but talking about some things that we're using this week, right? So for those of you who did the bonus challenge, you know, we use Terraform. This week, we are going to be using some of our task definition templates to actually go out and create some of the things that we need, right? So starting with our ECS events role, this is going to create a role for us. This is just the template. This is going to go out and create a role for us that allows us to do the ECS run task and the ECS describe task, right? Now, not to kind of jump around, but as you'll see right here, when we run this script locally, what this is going to do is it's going to take the environment variables in our .env file and inject them into our JSON file and create the actual file that will be used, right? So it's going to look at task.def.template.json. It's going to inject the environment variables in, and then it's going to create a task.def.json file for us. So anywhere you see template, just know that that's going on. Some of these that don't have anything injected into it, right? So injected pretty much just means like wherever you see this curly brace with the money sign, right? So you don't see those here, so nothing needs to get injected. So those JSON files just stay static. But this is the events role. It allows us to take this service and assume the role. All right, so we have our ECS target template. What this is defining the target configuration for an Amazon EventBridge rule that's going to schedule and trigger this ECS task. So right now we have this set up to run once a day. This is a S3 and a DynamoDB policy template. This is just configuring some IAM policies for our S3 functions and our DynamoDB table that we have to go out and run. And last but not least, this is all of the container definitions and configurations for us. So everything, a lot of what you saw in this .env file is getting created here with this template. Okay guys, so jumping into actual steps to execute, and once again, this might change a bit, but at a high level overview, I'm going to go over anything that's kind of different from last week when we were using containers. If this is your first time going through it, you'll be able to also follow this step by step and get everything that you need, but trying to avoid some redundancy. So right up here, it shows you how you can create your Rapid API account. If you don't have an API key to actually go out and get this data, that is going to be first steps. As far as the prereqs that are installed, for those of you who have been following along, largely the same of what we've already used thus far. The only new thing that you need to install is this git text package. This feature environment substitute or envirsubt, whatever that's pronounced. It's a command line utility tool that's going to be used for our environment variables to be substituted into our shell scripts. So there's some steps here on how to install based on what operating system you actually have. And then just steps on how you can retrieve your account ID and your access keys and secret keys. So first things first, like all of our other projects, you're going to want to go ahead and clone this repository locally. I use VS Code to run all of this. We kind of already talked about the environment file and what you need to swap out. I did include some scripts here you can run to generate some things. So like your S3 bucket name just has to be unique to you. So I typically like add my alias to like whatever is at the end. This shows you how to get your MediaConvert endpoints. And then if you didn't do the containers lab last week with us, this is how you can get a subnet and a security group. If you already did this, you can go into your AWS console and go search for subnets at the top, and it should show you your subnet ID and your VPC. And you should be able to use your VPC to get the security group ID and swap all of that good stuff out. Now that we've gotten all the files loaded up, we can actually get this thing running. So the first thing you want to do is actually load your environment variables with these three lines of code here. And to make sure that that has properly loaded, you can run this line of code. You could swap this out with any variable that's listed here in the .environment file, but AWS logs should return this in the output. If you don't get a return, you want to make sure that first and foremost, there is something listed there in the .env file. Secondly, you want to ensure that this is the correct source. It might not be able to find that .env file. You might need to update this path if you move any of your file structures around. But the fourth step we want to do is actually generate those JSON files. As we mentioned earlier, we just have templates in there that have placeholders that need variables injected into them. This will also be helpful next week when we get into our CI/CD pipelines or creating continuous integration and continuous deployment pipelines. We'll be able to use these templates to inject what we need into it. So this is going to go and look for this template file here, and then it's going to inject the variables into it and create a task.def.json file. So if you are doing this within Visual Studio Code, you will see new files actually be populated and created after you run each of these. So we're going to do that for the task definition, for the S3 DynamoDB policy, those IAM policies, the ECS target, and the ECS event roles policy. This is an optional step, but I feel like troubleshooting along the way kind of helps you from like identifying where the problem lies. So you can go and open any of those files that were created and just confirm that anywhere that something should be injected, there's visibly a variable there. If you see any like blank quotes, go back and make sure that either A, you didn't misspell something. Like if you mess with any of the variables, they have to be spelled exactly to inject them. And then make sure that they all have something entered into them. The worst thing that's going to happen is you're going to go to run this and it's going to fail. So it'll tell you where the errors lie, but trying to help you guys with like debugging on your own. These steps really are the same as last week when we were talking about containers. If you're not familiar with containers, definitely brush back up on my video and the bonus video where we talk about building containers locally and then building them where we could deploy them to an ECR repo. But essentially, we're going to create a repo or a folder for this container to get deployed to. We're going to log in and authenticate. Then we're going to build our Docker image, tag it, and push it to that ECR location. Now, we do have some additional AWS resources to create. We have to create our ECS task definition. So we'll be taking that file that we generated from the environment substitute command, and we will be creating that. And then we also want to create our Cloudwatch logs group. This is a great way to go and debug. If you have any issue or error, you can go to your Cloudwatch logs group, click through step by step and see what exactly is failing. Like I think in this example, you can see here that we are still getting this serialized error message. Error creating MediaConvert job. One of the type datetime is not JSON serializable. So I'll debug into that. I thought I'd put the fix in the code, but that's just an example of like, okay, somewhere in the MediaConvert .py file, something is incorrect. And so next we're going to attach the policies. So we created these roles, but now we want to attach the proper policies to them, and that can be found in that file that we just created once again with that environment substitute command. We are going to create a role also for our ECS, and it's going to assume this policy document here, and then we're going to attach the events role to the policy. So we're essentially, instead of doing all this from within the UI, we are now doing it from the CLI using scripts to attach the proper policies. Last but not least, we are going to then create an EventBridge rule to schedule the task. This is basically going to say, how often do I want to go out and look for NCAA highlights and execute this? So right now I have this running every single day. If you want to test that this event is working without having to, do this every 24 hours, you can simply change this to 1 minute and then it will run. I recommend you do that. You literally just do rate 1 minute, put 1 minute on the inside, and it'll run every minute. Make sure that you change this though, because your bill will be crazy if this continues to just run and download a bunch of data every single minute. But you can make sure that it is like triggering properly. I added the step down here though for you to manually execute this task. So if you copy and paste this block of code, it should then deploy the application to the container. And if you go to ECS here, I'm not going to have anything because I didn't run this. But if you go to ECS here, you will see this should say like pending. It does take like a minute or two to actually start running. But then you will see underneath of the logs in the ECS, if you click on it, you'll see under the logs steps similar to this being output. And so definitely excited to see what you guys built from this. I think this is a great kind of foundation for you all, but there's so much for you to tweak. Like I said, if you want to export any of this back into S3, you could do that. You can also import this from S3 from the last 30 days. I told you guys S3 also has versioning. So there's a lot of ways to track and ensure that like what data is going in there is saved in a chronological order in case you ever needed to revert back to anything. Maybe something crazy happens in the NCAA and you want to go back and get that data and then push that out to like your web application or something like this. This is really like DynamoDB is really useful in instances where like auditing and logging is very important. So think about like banking as an example, having certain like transactions or snapshots, the date and time of that is going to be highly critical depending on what it is that you're running and doing. So let me know down in the comments how you guys feel about this one, how you all feel about reusing some of the application that we did last week for containers to go on and back up that data. I'm excited to see how you all remix this. Be sure to head over and subscribe to Ifeanyi's channel. I'm going to link it down below in the description. He will be dropping a video tomorrow, closing us out on week 3. And then on Friday, I will drop the first Azure video. So that should be Friday the 7th. Yeah, Friday the 7th, I'll be dropping the first Azure video showing you all how to build out a NBA data lake on the Azure side of things. So a lot of learning to do, and I'll see y'all in the next video.